And moving on to question 10. All right, I'm gonna hopefully be able to do these questions very quickly. They're not hard if you do enough of these, I guess. But anyway, I don't know what I'm going on about. Let's get start. The first question asks you to calculate the number of atoms in 4.64 mole of aluminium. It's a very good habit to have to actually summarize the question before you do it, so you know what is being asked and what is provided. Also, this is when you start to have to be very consistent and accurate with the symbols that you use. So mole, this is number of mole, and number of mole is, okay, I think this is where my screen is cut off. Number of mole would be N, and I tend to write bracket of aluminium, so I know this is the number of mole of aluminium I'm looking at, which is 4.64 mole. So that's the number of mole. Now the question asks for the number of atoms, which is N, big N, so capital N for number of atoms or molecules or ions, so number of particles, and small n for number of mole. So this one asks, what is big N given small n? Now you can use the triangle if you don't remember the formula. Hopefully, eventually, you will get better. So basically, number of, oh, I even drew it wrong. That's great. What did I just do? Okay, the number of atoms or particles or molecules, so big N, is the number of mole multiplied with Avogadro's number. Now Avogadro's number is Na, which is 6.02 times 10 to the 23. You will be provided with this number, so you don't have to remember it. Also, I do hope that you remember it by the end of this year. So if you want to find big N, whatever number you want to find, you just cover it. Not entirely sure there's a way for me to do it with this little cursor, but if you cover the big N, then you can see that big N can be calculated as number of mole multiplied with Avogadro's number. So N of aluminium is going to be number of mole of aluminium multiplied with Avogadro's number. Now Na is not a scientific notation, so sometimes people use A, I think, or some other letters, but small n definitely is. So 6.02 times 10 to the 23. Please do not feel compelled to write out 23 0. I definitely would not appreciate having to count those, and honestly I don't think you have the time. Okay, if I just do this calculation between the first two numbers, I do get 27.93. So I'm going to write into scientific notation, which is 2.793. Way too many civic. 2.79 times 10 to the 24, and do have a unit this time. This is the number of atoms of aluminium you're calculating. That's part A.